Hello, calculus student. This is chapter 4.2, part 2. The second part of 4.2 is differential. What is differential? Differential is actually a new equation that we derive from tangent line. Okay, so it comes with a picture, so there are a lot of new terms. So first of all is delta x or dx. Dx means when x changes a little bit. And this is actually the same as dx. Okay, when you do the dy dx, that's dx. And then we have delta y. Delta y is change in y, the actual of x, x plus delta x minus f of x. That means actual change. Now, what is dy then? dy is the differential. So this is the distance between in the tangent line. What is the distance of the tangent line calculation that you have? So instead of f of x, it will be L of x plus delta x. Oops, where'd it go? Minus L minus L of x. So in the picture, so this is what it said. I have, this is a f of a, so that particular one. If I change x for a little bit, then my tangent line would also change, and this is dy. You see how dy is what the tangent line change when you have your x value changed to x plus delta x. But then the actual real value of f of x changed by delta y. So delta y and dy actually are different, but delta x and dx are exactly the same. So we have an equation like this. dy would, because it's on the tangent line, is f prime of a. That means at that particular point, dx. Okay, so what happened is you would just do a derivative of f of x, and you just put dy on this side and dx on this side, and that this will be a new equation that relay the change in y on the tangent line over change in x and x. So it's nothing. It's almost like you want to think about, oh, dy dx, the notation is just f prime of x, right? So so then you would say dy would be, if you multiply dx on the other side, would be dy would be f prime of x times dx. So that is what it is, but it is not valid for all x. It's just it changes in a different value of a. So in general, they would you need to say f prime of a instead of a general x. But I think you can just say f of x. So find a differential for the following function. So that means you need to do f of x, a derivative of x, because it's the slope of the tangent line. So what would it be? That would equal to our fig and gif again. Fig and gif. So fig is derivative of this one, which is 1 times sine x, plus gif is derivative of the sine x is cosine x, times f. So x cosine x. So that's our f prime of x. Once you do that, then you say the differential, you write this way. You differential dy is equal to sine a plus x cosine a. Oh no, I should say a cosine a times dx. That's called the differential equation. Sometimes in the book they just write x. It's fine. But you would know that when you plug in, you don't plug in this dx and dy. They are just one thing. You plug in here. Okay, you plug in here. This is not for plugging in. Second example. So this is the equation, and they would tell you, oh, if a is 0.5, what is dy? Something like that. That means when x changes a little bit, what would y changes? The second one, y equal to square root of 1 minus x. So let's do f prime of x first. Then basically you just do derivative. So this is chain rule, right? 1 minus x to the power 1/2. So the outside function is the square root function. So you say 1 over square root of 1 minus x. So 1 minus x to the negative 1/2, and then do the derivative times negative 1. So it becomes negative 1 over 2 square root of 1 minus x. So what's my dy? What's my differential? My differential would be dy equal to negative 1 over 2 square root of 1 minus a. Whenever you see x, you change a times dx, and that's it. So whenever if they tell you, oh, a is 5, if I change my dx for a little bit, what would dy be? It's used in calculating like error. If I measure my x wrong for like 0.1 cm, what would it change my measurement for y? When my whole measurement of x is 2 or 3 or something. So this is not, you can say that it's general for every value of x, so you can theoretically replace it with x, but we usually write it as a to distinguish from this x. Okay, so so that's what it is. You just write dy and then the derivative function and then dx, and this formula is called the differential. It's used in chapter 5, so that's why we need to cover it, and you need to know the terminology. Dy is the change on that you notice on the tangent line. Delta y is the real change where when you plug in the function at the function value. So we use dy to approximate delta y, and that's called a differential.